Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. And today we are talking about supplementary practice for unit 4.1, which is to do with energy. What is energy? Let's go. Let's give it a go. Let's get it done. Okay. So the first question asks us to identify what are the two different types of energies. Hopefully by now you know that there are two different types of energy, and those are kinetic and potential. Kinetic refers to the moving energy, while potential refers to the stored energy. That means it can be stored, right? So things like chemical energy, things like gravitational potential energy, elastic energy, those things can be stored and we call them potential, right? While kinetic energy is moving energy, and turns out there are a lot of things that we think of as being independent but are actually part of kinetic energy, things like temperature. So thermal energy is an example of kinetic energy. But if you're not sure, please go back and watch the video on energy. That will explain a lot better. This video is not about explanation, it's about answering questions. Please make sure you pause the video, answer the questions, and then check your answers. But if you're still not sure, as I said, go back and watch the original lesson, video lesson, please. Okay, so identify the energy an object has due to its motion. Let's have a look. The first one, what are the different two types of energy? We already talked about that. The energy an object has due to its motion is called kinetic or potential energy. Stored energy, so that's going to be kinetic due to its motion, because they said motion and motion means movement. Stored energy that results from position or shape of an object is called potential. Okay, so stored energy from the position or the shape of an object is called potential energy. What are the two factors that affect an object's kinetic energy? Well, kinetic energy, as we know, is, here we go, kinetic energy, or also, as I like to write it, energy K, which means kinetic energy, is equal to half times the mass times velocity squared. So the two factors that affect it is mass and velocity. Mass and velocity. So if you just write mass and velocity, that's correct. Mass and velocity. Okay? Applying concepts. What type of energy does a cup sitting on a table have, and why? So here's the table. Oh, this is tricky to write on this. Here's a cup. So this cup obviously has some energy. How much energy does it have? Well, it depends on how high the table is. Why does it depend on that? Because the type of energy it has is called gravitational potential energy, also known as GPE, gravitational potential energy. And the formula for gravitational potential energy is mass times gravity times height, also known as weight, times, let's just capitalize that, weight times height. And weight is actually mass times gravity, your mass multiplied by gravity. But anyway, so we won't worry about that just for now. So what type of energy does it have? It has gravitational potential energy because it has height, because it's sitting high up on the table. The more high it is sitting, the higher up it's sitting, the more energy, gravitational potential energy it's going to have. Okay, so an object falling from the third floor is going to have more gravitational potential energy than an object falling from the first floor. Okay? Okay, let's do some questions. How are work and energy related? Well, turns out work is transfer of energy. In other words, work and energy are very closely related. They have the same unit. They're both measured in joules. And this is what I always tell my students. If you see work, then just assume we're talking about energy. If you see energy, then assume we're talking about work. They are very closely related to each other. Work is the amount of energy transfer. So it's basically more or less the same as far as we're concerned. What is the power related to? How is power related to energy? So power equals energy or work done over time. That's how they're related. It's the rate at which energy or work is done. That's what power is. So it's energy over time. And another way of writing this is by drawing the triangle. So power, energy, time. Okay. What are the two basic kinds of energy? We've already talked about that. So it's either potential or kinetic. Kinetic. Right. A girl who weighs 30 kilograms, well, that's already wrong, who has a mass of 30 kilograms, because weight is in newtons, who weighs 30 kilograms is in line skating at a speed of 5 meters per second. What is the girl's kinetic energy? Well, we know that the formula for kinetic energy, I'm going to use symbols here. Energy kinetic equals half times the mass times the velocity squared. So knowing that, do we have the mass? Yes, it's 30 kilograms, so it's going to be half times 30 times 5 squared, which is equal to 25 multiplied by 15, which is equal to 375 joules. Now that's the main thing as well, is that once you find the answer, you really have to have the units. 375 joules, and the symbol for joules is a capital J. Okay, that's supposed to be a tick. Right, a hat that weighs 5 newtons, that's better, is hanging from a hook 1.5 meters above the floor. How much gravitational potential energy does it have? So once again, we already said that G P E, gravitational potential energy, is equal to weight multiplied by height. Do we have the weight? Yes, 5 newtons. Do we have the height? Yes, 1.5. So that equals 7.5 joules. That's the answer. Okay, hopefully that wasn't too hard. And now we've got some sort of matching energy. We have to match each term with its definition by writing the letter. Okay. Energy is, which one of those? Potential energy related to the ability to do work or cause change? Absolutely. That's energy. Kinetic energy, that's the energy an object has due to its motion. No thanks. Okay. Here we go. Potential energy. That's the energy that's stored energy. First of all, stored energy that's due to an object's shape or position. Gravitational potential energy has to do with height. So that's A. And finally, just through process of elimination, it's going to be C, but let's read through that anyway. So energy associated with objects that can be compressed or stretched. Absolutely. Okay, let's move on. Write the letter of the correct answer in the line on the left. The kinetic energy of an object is equal to 1/2 of its mass. 1/2 of its mass, yes, multiplied by its speed squared. Now I just want to point out something. If it says write the letter, then you write the letter. If it says underline, you underline. If it says you circle, you circle. If it says tick, you tick. Try and be consistent and be accurate with the way you answer your questions. Okay, next, number 2 says the gravitational potential energy of an object is equal to its weight multiplied by its height. So I'm circling it, but I'm also adhering to the rules by actually writing the letter. Number 3 says energy is the ability to do work or cause change. We could not cause any change or do work without energy. If you're finding this lesson a little bit tricky and difficult, please go back and watch the original video, okay? Which I will leave in the description below. Number 4 says energy and work are measured in joules. Okay, fill in the blank to complete each statement. When you do work on an object, some of your energy is transferred to that object. Oops, what did I do? It's transferred double R. I think it's one R. Transferred. I think it is double R. Power is the rate at which energy is transferred. Once again, isn't it? Potential energy results from what? From the shape or position of an object. Shape. A stretched rubber band has elastic potential energy. A change in the object's speed has a what effect on its kinetic energy than a change in its mass? It has a bigger effect. A change in its speed has a bigger effect, and the reason for that is the formula. So half mv squared. You see velocity, it gets squared. So if you double the velocity, you're actually quadrupling the amount of energy because of the squared. So it has a bigger effect. And once again, if you don't understand that, please go back and watch the original video. It explains all of that. A mountain climber at the peak has gravitational potential energy, has a lot of gravitational potential energy. How are we doing for time? I think we're quite good this time. Gravitational potential energy, also known as GPE. Okay, thank you so much. Hopefully you understood that as well. See you in the next one.